Hello, my name is İnci. I'm a student of Electrical and Electronics Engineering at Bilkent University. In this video, I will be presenting you my term project for EEE102. For my project, I designed a basic interactive game. In this game, a player tries to pass the ball inside the gate, while this obstacle is making an opening and closing movement. And if the player successfully passes the ball inside this gate, a point will be received and it will be shown on the 7th segment of the basis tree, and therefore we can understand that the player did a successful throw.
For this design, I used an FPGA board basis 3, jumper cables, a breadboard, a servo motor, infrared sensor, some Lego bricks to build this gate, this extra plastic piece with 10 centimeters length, and a ball. To program the device, I wrote VHDL code. I used Vivado's 2022.2 version of it. In the code, there are several modules. Servo module determines the behavior of the servo motor. The motor rotates 90 degrees towards one way in 0.5 seconds and goes back to its previous state in 0.5 seconds again. And this sequence continues automatically. IR top takes the signal from the infrared sensor. The infrared sensor sends logical low signal when it detects an object in front of it and sends logical high signal when there is nothing in front of it. According to this signal, a counter variable was declared. This variable incremented by 1 whenever the signal of infrared sensor is 0. This value is used to be displayed on the 7th segment display of the basis 3. Also, a debouncer module was added to avoid arbitrary increase on the display. When I first implemented this design to my system without adding a debouncer module, it displayed arbitrary increase on the 7th segment display, but after I add the debouncer module, it increased like I desired one by one. These external components are connected to the board using jumper cables. I assigned P-mode header JX ADC's first pin to send signals to the servo motor, and P-mode header JA's first pin to infrared sensor's D0 output to take signals from infrared sensor. Furthermore, in this design, if the upper button is being pushed, the motor stays in its last position till it's released. And to reset the score, the button at the middle should be pressed. As you can see, the display turned to 0000 again. In conclusion, the development and implementation of the game project were successful. Through the integration of an infrared sensor, servo motor, and 7-segment display, the game provided an interactive and engaging experience for players. The motor functioned properly, adding a feature to the game that challenges the player's hand-eye coordination. The infrared sensor accurately detected the ball, and the player's score was incremented and displayed in real time on 7-segment display, which allows players to strive for higher scores and also monitor their progress. With all these features, this project provides an engaging gameplay experience.